Hello. Hello. Yeah, I guess I'm audible. Um, class, uh, this will be our final webinar on this image classifier project. I guess we already have 4 to 5 webinars for this project, and to have a live webinar, we need to bring all of you to the same page. Many of you have successfully submitted this project, and many of you are still struggling with it. So, some of you were earlier struggling with it, but after a few one on one sessions with me, they also successfully submitted. But many of you are not really reporting or letting me know where you are stuck at. So I'll suggest you guys to book the one on one slots if you are having problem with this image classifier project. So all the modules, all the sections of the project that were needed to be solved have already been discussed and explained thoroughly in the webinars. So even if you have not started the project yet, you just go through the videos once and you will get a good idea of what they are all about. And I don't think it will take you after watching the videos and applying implementing the project side by side, you won't need more than 2 to 3 days to complete it. Yeah, the training time may take some time depending on the your network, I guess, because most of the time when I used to run training, the workspace goes idle. So it happens when you keep your system inactive for say 10 to 15 minutes. I would suggest you guys to keep checking on your training while doing at it. And further announcement was that we'll after discussing the video, after discussing the project, we will be discussing the next section of the nano degree, that is the term 2. So few things you need to know about it. I'll discuss all of those modules in detail, which will be the topics of the term 2. And also your term 1 will be completing on July 6th. So if you complete your projects before July 6th, it will be well and good. Even if you don't, you will have a grace period of 1 month. That is, you can submit all your projects and complete your term 1 degree till August 3. This is a 1 month free extension. After that, I guess you will have to pay for submitting your projects. So you won't get a degree then unless you pay for it. You will have the course subscription, the videos, lectures, and everything else, but unless you get complete all the projects, you won't be able to get the certificate. So I'll suggest you guys to complete your projects on time before August 3. August 3 is the latest date. After that, you will have to pay for it. So if you already have paid for the project, and I would suggest you guys to try to complete it till July 6th. And even then, if you are having problem, then just finish it off till August 3. That's the last deadline you will have. Okay. Other than that, yeah, we will be after next from next week, we will be jumping on the unsupervised learning part. So we will be having the live webinars for that topic itself. So we'll be discussing few topics, and then we'll move on to the next project. And let's have a project overall overview. Let's have the final discussion on the project, and then we are good enough to jump to the unsupervised learning part. Today in this webinar only, I'll be also showing you the term 2 of the nano degree. You need to complete both the nano degrees to terms to get a nano degree. So just finish the first part very as early as you can, and then we can jump to term 2, right? So yeah, let's just start it. Okay. So now my screen is visible, I guess. Okay. Uh, so this is your project, the classifier project. We have seen it multiple times. Now we will be seeing it one last time. So this you need to complete on PyTorch using the GPU workspace, right? There is CPU option and GPU option. You won't be able to do the training on CPU, so you will need to access the GPU workspace. There is around 60 hours allocated time for you initially, so that Hello. Yeah. So the time completes after you. So the time is of around 60 hours, and since the training takes a lot of time, so you need to invest them very carefully. Those 60 hours. Okay. Now let's move on to the next part. Yeah. So it will be asking me an option whether to enable it or not. I'll just enable it. Okay. So it will take some time for GPU workspace. Yeah. So the project is you get a picture and you need to identify which kind of flower it is. You have a data set of 102 flower categories. You first need to load a pre-trained model like VGG16 or DenseNet, and then you have to attach your classifier with it. Then the whole model with the classifier, you need to train it on your data, and then you need to save the checkpoints, and after saving the checkpoints you can always train it further. You can load your model again and then predict for a particular flower entry, right? So here are the all the libraries imported. So this PIL I have imported for image processing. Other than that, all are known to you, right? Then there are data directories called flowers, and inside flowers there are train, test, and valid data set. Then there are some transformations. So if you have seen it multiple times. So for training we are doing this kind of transformation, for testing we are doing this kind of transformation. So transformations are nothing but they tell you what you need to do for particular image entry. So for all the training data sets, it will be randomly rotating it by 30 degrees, then resizing it, then horizontal crop, then converting to tensor. And converting to tensor is quite important because PyTorch works on tensors, right? So tensors are like kind of vectors entries, and you need to understand them, and then you normalize it. Normalize is the first part is your mean, the second part is your standard deviation. So the formula is x minus the entry minus mean upon standard deviation. So this works on that basis. Okay. Now this cat2 name. So this cat2 name is actually the file that tells you the corresponding name to a flower category. So it's like a roll number mapping to you. So like one number correspond to a particular flower A, and uh, uh, number 37 will correspond to another particular flowers, let's say C. So this kind of thing, right? So here one corresponds to pink primrose, 34 corresponds to Mexican Ester, 48 for Lenten rose, English to marigold to 5. So there are around 102 categories you need to know, right? Uh, okay. So first we load our model. So here I have loaded VGG. You set the pre-train to be true. So VGG is trained on ImageNet dataset, and here your VGG looks like this. It already has a classifier attached with it, but you need to build yourself a classifier, and then you need to so since this classifier is for like 4096 output, but and it outputs 1000 categories, but your particular data case has 102 classes. So you need to um, build a classifier accordingly. So here what I have done is, so I take the output from the VGG 25088 and pass it to my next layer, that is my 4096 linear layer. And then I apply ReLU, then apply dropout. I apply ReLU because I do not need vanishing gradient problem here. And then 4096 to 4096, then 2000, and eventually to 102. So that means it will give me probabilities for my 102 classes, and then I can output the particular flower entry, right? Okay, so now here I set my device to be the GPU or CPU. So I am applying it CUDA whenever CUDA is available. Else I am applying CPU. So Optimizer I am applying Atom. You can try something else, but Atom works quite fine on this. Now this function is for my training deep network, right? So I pass training data, valid data, epochs, and print every. So print every is the number of iteration that after which I want to print the data set. Print the not the data set, actually the accuracy and all those things that I can use to understand the behavior of training, right? So I initialize steps, running laws, and criterion to something else, some specific values. Then I apply my model to the GPU. So for particular number of epochs, I take the training and testing data. I apply the training. I do uh, back propagation, and then after every print every steps, I print the losses, and I also print it for validation data set, right? So after training I check it for my validation also. And you can see that result of my training, it looks like this. My training loss and test loss, eventually they are decreasing to some values, right? So it is not completed here. You can complete your training, and then testing using the same model, I just apply it on my testing data set and check my accuracy here, right? Saving the checkpoint is quite important, so for that I would recommend you this link, saving and checking checkpoint, save and checkpoint torch. I tell you the link for PyTorch. Yeah, this one. So PyTorch tutorial, this is saving and loading models. This is a very thorough tutorial. It will tell you each and everything you need to know about saving the particular checkpoints or the model or your specific dictionaries, right? And yeah, so that's about all about it. So about saving the checkpoints, you need to understand the statics tells you the how the weights are associated with each other and their values, right? And also you need to save the dictionary state of optimizer. Then you save the checkpoints. Then for loading the checkpoints, you do not need to do anything else. You just create a new model, and in the place of the dictionaries of that model, load the one where from your checkpoint, and then your new model will be same as your trained model. So you see, you do not save the model, you just save the checkpoint, and then you load it on any new model that you are creating, right? After that there is image processing step. So here you need to understand this a bit further. So I have done this like this way. So this is quite easier for you. This is also mentioned in some exercises. I won't go much into it, but I already have discussed in I guess last to last webinar. So this is mainly about the same thing. This actually is like the same thing that we did in the transformations. So here we are doing some specific processing for the images, and here you show the image, right? For class prediction, you need to do these functions. So what this function does is it loads your model, it takes your image, it pre-processes it, and then it passes the image to the model. It gets the probabilities, and then according to the probabilities, it picks out the five best highest probabilities and five highest class flag categories accordingly. So, for example, for this particular picture, you got these five topmost values. So, for this class stemless gentian, you have this probability. For monk shoot, you have this. Canterbury bells, you have around this point one. For grape hyacinth, and this, and bolero deep blue is this. So why do we see only the top five classes? Is because after five classes, the probability of all the remaining classes is almost negligible. So you do not need to take consideration of those, right? So this will complete your first part of the project. This is it. You just complete all those sections, check out the webinars, check out how I have done each and every section, and then just put those code here and run it. It will be quite easy if you go through that way. And now when we go to next part, this is about command line. I have created a separate webinar for this. So here I won't go into detail. I'll just tell you the what it is asking for. So it should have two files, train.py and predict.py. So the train.py takes the data directory for training to run to, and all the parameters that it can need, like the GPU, whether you are running on GPU or CPU, what is your learning rate, what are your hidden units, and what is the pre trained model that you are using. So these kind of things you need to pass in the argument, and in the predict.py you just need to pass the path to the image and all the same kind of attributes. Not all of them, because learning rate is not required here, the VGG is not required here, GPU might be required, so you need to pass that. So, and also the cat this file is actually the your which gives you the name associated with the particular flower number, right? So after running your classification, all you will be getting, let's say, you will getting, let's say, 50% probability for class 1, 10% probability for class 37, 40% for class 53. But you do not actually know the flower name of this class unless you refer to this get to name JSON file. So this has all your flower names associated with each and every class number. You need to take that into also into consideration. And then there is a arc pass tutorial. Right. So this ArcPath tutorial has everything that you need to do. I already have discussed in this about this in one of my webinars. You can check that out, and that's not really a big deal. You just need to define your arguments and then pass them in the terminal, right? So if we go to the next step is your command line terminal, where you will be actually doing that stuff, right? So it will take some time to load. Okay, so it has loaded. Now we will see it. Okay, so this is my train.py and this is my predict.py, and this is my workspace. Okay, just let me see whether it is loading it. Okay, I guess it's hanging here. Yeah. Okay, so now let's see. So this is my Flask data set. It has three folders: train, test, and valid. And it has my train.py, main.py, predict.py. These three I have made myself, and then this is cat to name JSON. So cat to name JSON, it's exactly just like a dictionary. For each class number, we have the flower name. Okay. What how we are doing it is like, so we go to the train.py and we go to its main function, and then we see the different kind of argument we are defining. So data directory is my default argument. It already is defined here. And then I have my save directory, and GPU argument is also there, right? So this is your default argument. You need to pass it, and the other are your optional arguments. You can define it and pass them accordingly. So here I am passing the save directory and GPU. You can also add the learning rate and all that. So this function will be then complete. And yeah, after that you run it. You are actually asking for the run train method. The run train method, what it does is it goes here and it sets your data directory from your arguments, save directory from your arguments, and GPU from your arguments as well. Then runs some transformations like you used to do earlier. So you just need to take the code segment from your first part and attach it here to specific files. So after you learn the training, you go to training deep network. So training deep network has your train function here, and that's all. You can also create so I have not added here, but you will also need to add here the save checkpoint function part. After that it will be complete. Okay, so this will conclude your training part, and in the predict part also. So you go to the main function and you see what all the arguments are there. So here there is data directory, there is save directory, GPU and image path. So I check all those arguments in the args part, and then I go to my run prediction part. So in run prediction part, I have set my data directories and I apply some transformations. So this part I have not completed, but you can complete it. So in the predict function, I take the image path and saved model, and then just take the predict function from the first part here and attach it here, and that's all. So that will do the stuff. And the top labels that you get, you just need to refer from this from cat to name. You just need to pass cat to name, square brackets, top labels, and you will get the all the five flower names. Yeah. So after you do it, you need to check the rubric for the course. You need to make sure that you have done everything, and then you can submit your project here, right? Okay, so that will be all. So I expect you guys to complete it, and like next week, before the next week's webinar, and then we can jump onto unsupervised learnings, because few students have started unsupervised learning, and we cannot really move to that part unless you complete this part, this project and all the concepts well. So deep neural network is very important part of machine learning. In your typical data analyst job, you may not find it quite applicable, but in any role that you take, like data scientist role, you will be making use of it quite a lot. So which is our target here, right? We want to make sure that you make a career in data scientist job, right? So now we can go. So this is unsupervised learning. So here the topics are clustering, density-based clustering, hierarchical clustering, Gaussian mixture models, dimensionality reduction, and PCA, random projection ICA. So this is also quite lengthy. So you need to make sure that you also do it on time, right? So now coming to term two, I'll briefly introduce you to the term two. So the term two is for those of you who successfully complete term one and then you enroll to the term two. For that, you need to pay for term two, and you can start anytime you want, right? But you will get the nano degree only if you complete both of the terms successfully, right? Okay. So the first module is Introduction to Data Science. So here we will be building your profile as a data scientist. You will need to be writing few blog posts where you will be discussing your projects, like your image classifier project. You will be discussing what all data sets you used, what all functionalities you used, what particular hyperparameters you used, and why did you use those particular values, and what are the different values you got. and you need to make sure that the whole blog is quite colorful. You have all those charts and graphs, and any newbie can understand your blog just by reading it once. And then you need to have your GitHub profile. For those of you who do not know what GitHub is an open source platform, so where you can professionally collaborate with other colleagues and work on a common project. So you need to make your profile in that as well. Then comes the software engineering part. So software engineering is quite important because software engineering practices make you a better coder or a better programmer. And a data scientist typically do not really just, you know, apply some models and then work on it in real life. They need to integrate it with proper working softwares. They need to integrate it with proper functioning, and for that they need to code in a particular way. That is called object oriented way also. So you need to know all the software engineering practices. So you make sure that you are that you complete the holistic approach to learning, right? So many of you already are from computer science background, so those of you will find this part quite easy. But those of you who are just starting it, this will be quite informative, and believe me, this will help you in improving coding a lot. And then you will be making your own Python packages that other people can use. For example, right now you are using packages that other people have made. You use them by importing them in the Python files. Now you have to make your packages such that others can also import it. Then there will be web development also. So you see, this degree is making sure that you get all the skills needed that are expected from a data scientist, and many more, right? Web development, and then deploying your systems to a particular data dashboard. These are all kind of cool things. So second part will take this degree a notch higher. You will have to work really hard in the second part itself. So first part was about concepts and basics building. Second part is about applications and applications. Now here you will be learning about data engineering, natural languages, ETL pipelines, NLP pipelines. So natural language processing is quite hot right now, so you need to learn it as well. Machine learning pipelines, and then all, and then you will also be investing your some time to improve your LinkedIn profile. Many of you might already know LinkedIn. For those of you who do not know, LinkedIn is like a professional career building social platform. So uh, you make your profile, you tell people about your professional experiences, your educational experiences, your internships and jobs, and they then you can find a suitable job accordingly, right? Then experimental designs. Yeah, so second part of the MBA degree is quite heavy duty, so it will take some time, more than like 4 months to complete this one. So make sure, so if you are already tired, have some rest, and believe me, after completing the term one, have some rest, and then believe me, the term two will be quite heavy. You will have to work a lot harder, and then you will be making some cool recommendation engines. Recommendation systems are those systems that help you make a choice of your own, like choosing a particular movie, or choosing a particular uh, so choosing a particular movie from ratings, or choosing a particular dress or clothes, or choosing particular which ads to watch. These are all kind of things that recommendation systems do. The data science capstone. So this will be a long project, and this will make you solve a real life problem using all the skills that you have learned throughout the program, right? Yeah, after you complete it, that will be great, and we can really have a blast after that. So if so many of you are based in Europe, if I happen to visit in Europe, we can have a meetup. We all can meet after you complete this part. So I'll be very happy to meet all of you guys. And then there is extracurricular for those of you who want to know a few things like SQL, all the prerequisites that were there, right? SQL, linear algebra, and all those things. Yeah. So that's all about it. That's all I wanted to discuss today. I would recommend you guys once again to complete all of your projects on time, because It really helps. You already have paid for this degree, now you have to complete it on time. So this will be a really motivation, a good motivation for you, and you will be able to complete it on time. After that, you will be able to land very very good jobs in data science. Depending on the country you are seeking the jobs in, you will have good opportunities. I know the opportunities in US and Europe, they are plenty. So they are more than in India, where I am currently based out of. So you will have plenty of good jobs, and you will be recognized in your field by the level of skills you will get through this degree. So with this, I'll like to complete this webinar, and hoping to meet you next webinar, and then we will be completing discussion on unsupervised learning. Okay, so see you next time.